Okay, I'd like to get started. Okay, so we are doing number 93 to start out with on page 117. So hopefully you've got your book open so you know what we're talking about, okay? All right, so they give you a position function. So S of t is equal to minus 16t squared. Guys at the front here, get your book open, okay? Plus V0t plus S0 for free falling objects. In other words, you drop something, okay? I mean, you either drop something or you throw it. Either way, it's just falling freely, okay? And then they tell you, the sentence says that a silver dollar is dropped from the top of a building that is 1362 feet tall. Part A, okay, determine the position and velocity function. So first of all, the position function, okay? So when you're dropping things, yes, go. When you're dropping things, Christian, when you drop things, what do you think the initial velocity of the object is going to be? Nice. So V0 is 0. Okay? So this guy becomes minus 16t squared. And from what height are you dropping it? 1362. So this S0 is, S0 is the initial height of the object. Okay? So that's your position function. What's your velocity function going to be? Remember, the velocity function is the derivative of the position function. So this becomes negative 32t. So everybody with me on that? And then part B, determine the average velocity. And we did this yesterday in the interval 1 to 2. So it's going to be S2 minus S1 over 2 minus 1. Can you guys chug for me and get me an answer on that, please? So you guys know what to chug where, right? Yeah? Nikhil, you with me? Can you do the chugging for me? While you're eating your bagel or your paratha? What is it, paratha, hopefully? With pickle. And dahi. And dahi. That's a traditional breakfast, right? Indian breakfast. Paratha, pickle, and dahi. Yeah, when I was in Bombay, that's what you were served.
It's not a pickle, but
it's not?
No.
Oh, it's not the kind of pickle you put on a hamburger. No. This is desi pickle, man. That sets you on fire. Sets you on fire. Yeah, it's pretty hot stuff. Okay, Nikhil, I'm waiting for you, man. Yeah, don't mind my mouth. Okay, it goes on and on. Come on, chug it, dude. Got me? Bye. Sorry? Negative 48 in the units. Feet per second. Yeah, if it's 16, then it's second. Okay, is everybody all right on that? That's the average velocity. How about finding the instantaneous velocity? So you want S prime of 1. So you're going to come in here and shove 1 in for t. So you'll get negative 32 feet per second. And S prime of 2 is equal to negative 64 feet per second. Is everybody okay on that? All right, and part D, find the time required to hit the ground. So, Christian, let me ask you this question. So here's your position function, okay? When it hits the ground, what's the S value? 0, right? Because you're measuring from the ground up. Okay, so you're going to get 0 equals minus 16t squared plus 1362, and you guys know how to solve that. Okay? And then it wants you to find the velocity of the coin at impact. So whatever answer you get out of here, can you give me an answer on that? Sorry? 9.22. Okay, you know what? You want to store this guy, okay? Store it. Do not write it down. Store it in your calculator. Do you guys want me to go over that? You guys okay on that? How to use store recall on your calculator? Go over it? Okay. So this is going to be square root of 1362 divide by 16. Okay, so do not write 9.22632. Okay, don't write that down. Here's how you store. See the STO button here? Okay, STO right above the on button. Okay, and store it, let's say, in alpha A. Okay, Nikhil, you with me? All right, so now the whole position is stored in there. And you want the velocity at that particular time. So what you're going to do is you're going to take that number and shove it in here and shove it in there. Okay, so this is how you're going to do. You're going to go negative 32 alpha A. Okay, yeah, that's pretty fast. So the point is, never go on top of a building that's 1362 feet high with Nikhil. Okay, it'll push you off. And then you're going to hit the ground at negative 295 points feet per second. And sure enough, you'll crack your bones. Yes?
So this is all assuming with no air resistance?
That's right. Yeah. No air resistance. Yep. Question. Did someone else raise hand there? Christian? Oh, okay. Looky here. Start over again. Go second square root. 1362 divide by 16. Okay. You find the STO button right above the on button. Okay. Who's guilty? Who's guilty? Suleiman. Who's that? Whoa. Read the sign there. Yeah. Who's that?
Tita's little brother.
Suleiman's little brother?
Tita's. You know Tita? In your. Like,
Oh, okay, Tita. Yeah. Okay. Fucking racist, man. Okay. Christian, you with me?
Yeah.
Alpha A. So it goes, you've got A through Z, okay? You can store, and I think you can store in numbers as well. I'm not sure, but you might want to try. So once it's stored, then you can always recall it by 16 alpha A. You don't have to go recall. If you just type in alpha A, it gives you whatever is in A. Oh, how come it gave me a different number now? It should have been 32, right?
Yeah.
Negative 32. All right? Guys, with me on this, Christian? You okay? All right, moving on. So the next one was 95.
Yeah.
Similar, do I need to do that then? Well, I mean, I need to go to 97, I need to go to 103. It's identical. 95 is the same problem as 93. Seriously. There's no difference. Okay? Is everybody all right on that? Aaron, you okay? All right. Moving on to then 97. Okay? And they give you a graph there, okay? It looks kind of like this. Okay? Goes up like that, then stays flat, and then goes up like that. And they give you the coordinates of these points. So this is 4,2, this is 6,2, and this is 10,6. And your x's are time and displacement. Okay, that's your graph, distance or displacement. Okay, so distance is in miles, time is in minutes. And if you read the question, it says the graph of the position function is shown. It represents the distance in miles that a person drives during a 10-minute trip. Make a sketch of the corresponding velocity function. So remember, the velocity function is going to be the derivative of this, right? So remember, the derivative is going to be the slope of the line. So what's the slope of the first part here? 1/2, okay? So it's going to be a constant velocity at 1/2, okay, miles per minute. You guys with me on that? And then what happens between the times 4 and 6 minutes? That's right. The guy's not moving, so the velocity drops to 0, stays at 0, okay? Oh, I thought you went to go get your book. Yeah, where is it? Yeah, what? The combo. Isn't your bong in there? How can you forget that, man? Combo to your bong locker. Oh, I see. Okay, and then Hiba. What's the slope of the other line now? Which be 1, so it's going to jump up to 1 and go like that. So this is 1. Okay? You all right with me? Okay. Next one, 103. Okay, so number 103. Ooh. Okay, 103 reads the volume of a cube of size S is given by that. Find the rate of change of the volume with respect to S. Okay, so you've got a cube here. Okay, it's S by S by S. So volume is S cubed. Okay, they want the rate of change, dV by ds. That's what the rate of change is. So rate of change, normally with respect to time now, I think it's with respect to S. When the sides are changing, the volume is changing as well, right? Right? So they want to find out what is the rate of change of the volume as the side is changing. Okay, so if you differentiate this, what do you get? 3s squared, right? This comes down and you reduce 3 by 1. Okay, so remember this is going to be change. So dV means change in volume over change in side. Okay, and all they need to do is find out when S is 4. That's going to be your rate of change of the volume. So that's going to be 48, no units apparently, no centimeters. So 48, wait a minute, find the rate of change of the volume with respect to S. So this, what should the units of this be? Let's think about this. What should the units of this be? What are the units of volume? Well, in this case it's going to be centimeter cubed because it's volume. Yes? And at downstairs, the side is in centimeters, so your unit should be centimeters squared. Okay? You guys all right on this stuff? Yeah? Okay. Moving on to today's lecture then. Probably around Christmas time, just kind of chill before Christmas time. Well, don't you want to chill around Christmas time, get in the mood for... Okay, moving on to a whole bunch of rules, okay? Moving on to a whole bunch of rules. I told you that tomorrow we're going to be working in the cafeteria, right? In groups, okay? I've already put you in groups, okay? And so what I'm going to do is I'm going to have problems, 6 problems posted around the wall, okay? And you'll be in groups of 4, maybe 5. Okay, there may be one group of 5, but you will be going from one station to the other, and every person in the group should be answering the question at least once, one of the questions. Okay, there'll be only one piece of paper to work on, basically. All right, so right now, today we're going to learn how to do the product rule and the quotient rule. Okay, in other words, when functions are being multiplied. Kevin and Chris, wake up, Chris, at the back. How can you sleep with my pretty strange Indian accent, loud voice, vulgarity and all that stuff? How can you fall asleep in that? It's soothing. Are you kidding me? My young girls used to cry when I used to put them to sleep. Go away, Dad. I was a pretty mean dad. I'm on record for that. Pretty mean dad. But not anymore, I think. I've learned. You awake, Chris? Did I wake you up? Oh, you want sleeping just with your eyes closed like the fish? Okay. Yeah, that's how fish sleep, right? Yeah, they sleep with their eyes open. Okay, so I have a product of 2 functions here. John, what 2 functions are there that are being multiplied? Nice, x and sine x. And I want to find the derivative of that.